Hey guys, what's up? Let's go ahead and let's get through these notes. So we're going to be talking about the elements combining to form compounds. Let me get my little pen in here. I like to use the little crayon, sorry. So these are all compounds that we see here. That's a compound, that's a compound, and that's a compound. So we're going to talk about how we actually can form compounds. All right, so first we have to start off with a term called ions. And an ion is something that forms when an atom is able to lose or gain electrons. Some of the atoms in the periodic table are able to, or actually most are able to lose or gain electrons, okay? And they're going to fall into two categories. They're either positive or negative ions, and that relates to whether they're losing or gaining. So for right now, just believe me when I say an ion forms when an atom is able to lose or gain an electron, okay? To be a positive ion, okay, positive ions, they're also called cations. These are ions that want to, or these are atoms that want to lose an electron. So positives lose, positives lose. So positives lose, positives lose. What it means is that these are, they have that maybe one or two stubborn little electrons that are kind of hanging out, and they need to get rid of them. Okay, and we talked about sodium in class. So we've got, based on our drawings, we know that the first circle can hold 2, and the second circle can hold 8. This third circle can hold 8, but it's only got 1. So it's easier to get rid of the 1 than try to find 7 more. Okay, that's a positive ion. Negative ions, like chlorine, so negative ions, they're also called anions. They want to gain. So negatives gain, positives lose. Negatives gain, positives lose. Okay, so negatives want to find one or more ions, or one or more electrons. So we know 2, 8. This can hold 8, but we only have 7. So if we could find something to go right there, we'll be okay. And it'll make this chlorine atom happy and not so crazy killer on us. All right, so why do the ions form? These ions are going to form because these elements on the table all want to be stable, and there's only a very small number that are stable, and those are the noble gases. So that is why those noble gases are so special, because they have nothing. They don't need to seek anything out. Here's neon, okay, and so neon's got 2 in its first circle, and it's got 8 in its second circle. It doesn't have to gain anymore. It's full. So it's like, yeah, I'm good to go. I don't need anything else. All the other atoms on that table, besides the noble gases, they're seeking something else. So they're not stable, okay? And their level of stability is going to change depending on how many electrons they need to lose or gain. But because neon is set to go, it's like, leave me alone. I'm good. All right, so from those ions, they're seeking something out, and they're going to get help if they partner up. And that's going to form something called a compound, okay? A compound is made up of atoms of 2 or more different elements, okay? So I can't just put 2 oxygens together. That's not going to make a compound. But if I put H2O, now I've got a compound. I've got hydrogen and I've got oxygen working together, okay? They're helping each other out. And kind of think of the this little example right here. So 26 letters in the alphabet, but we definitely have more than 26 words in our language. You just need to change letters around. Sometimes we have to double a letter, and it makes a slightly different meaning. That's the same for the elements. So we have 92 naturally occurring elements, about 118 on the table right now. But there's more than 118 things on the planet. We just have to put them in different arrangements, and that's what makes different stuff, okay? The things that are going to hold these compounds together are something called a bond, okay? And I want you to think of a bond like holding hands, okay? So I'm holding hands with myself, okay? The harder I hold them together, the stronger the bond, which means it's going to take a lot of energy to break this. But if I'm just holding my little fingertips, it's not going to take much to break it. So some compounds are held together like this. It's not going to take much to break them apart. Some compounds are held so tightly together, it's going to take a lot to break them apart. You don't need to know in terms of the differences, just understand that a bond is holding hands. Some are stronger than others, okay? Oh, wait, I jumped ahead, sorry. So, some factors that determine, I'm just following along with my notes, make sure I don't skip anything. Some factors that determine the properties of a compound, okay? The first thing is the types of atoms that that compound contains. That's going to determine its properties. So if it's, metallic, if it's malleable, if it's it has a melting point at a certain temperature, that's going to determine the properties of the compound. Those two atoms singly, when they combine, it's going to determine how that compound is. Okay. And the other thing that works with it is the arrangement of my atoms. Okay. So all it is a matter of is taking the hydrogens and maybe flip-flopping them in a compound. If I had carbons on one side and hydrogen on the other, and I flipped it around in an arrangement that I had hydrogens and then carbons, that's going to kind of give it, that's going to change it, okay? Think about anything you have. If I have plain water and I pour sugar in it and I stir it in, I've changed the water. I've changed the composition of the water. The water's not going to taste like water. It's going to taste very sweet. The same idea with these, the properties of a compound. The atoms themselves are unique, but once I put them together and I rearrange them, I'm going to have different properties depending on that arrangement. Okay. When I represent a compound, I use something called a chemical formula, and this is a chemical formula. So CO2 is a chemical formula. This is why you guys need to memorize your elements. You're familiar with H2O. Okay. Those are chemical formulas, and it's giving me what the chemical or what the atom is and the ratio of that atom. So if I see a number next to an element, so if I have, let's say I'll put my CO2, that number right there tells me how many oxygens I have. So when you see a number to the bottom right of the letter, that's how many I have. If I don't see one, like in this example with the carbon, that is understood to be 1. Okay, you don't have to write a 1 in. It's understood to be 1. Okay, so this tells me I have 1 carbon to 2 oxygens, and that's its chemical formula for that compound. And in class, we'll go over how to actually name these and form these. Okay, so how do we form compounds? And here's that question up at the top. How do I form a compound? I'm going to take my compounds, and I'm going to it's kind of a way of remembering it. We're going to say they're givers or they're grabbers. So if I'm a giver, I want to give up an electron, which means I'm a positive ion. If I'm a grabber, I want to grab the electrons. That means I'm a negative ion. Okay, so it's a kind of a way of, okay, givers are going to give, grabbers are going to take. An ion, a compound is taking that giver and that grabber and bonding them together. So they're working together. I need to give one, you need to take one. If we work together, we make a compound. Okay, so let's look at some givers and grabbers, and these are not by far all of the givers and grabbers. They're just a couple of them, okay? The number up here represents how many they either need to give or take. So if I have a positive 1, that means I need to get rid of 1. If I have a negative 1, that means I need to gain 1. Okay, so I'm in a deficit of 1, whereas a positive means I'm over. I have 1 extra. Think of it like that. This is simple math, okay? If I have a positive over here, positive 1, and let's say chlorine has my negative 1, and we work together, 1 plus 1 and a minus 1 is 0. It cancels itself out, and I have made myself stable. So that sodium and that chlorine combining together and forming a compound makes sodium chloride. Okay, and that is a stable compound, and I've chilled out. And you can see all these different examples on here. Now, don't think I have to go plus 1, minus 1. Okay, we have all sorts of compounds. All I have to do is make the math work. Okay, some are easier than others, but for now, you don't have to just go a plus 3 and a minus 3. Aluminum could bond with these minus 1s. It just is going to take a couple of minus 1s to fulfill its plus 3. Okay, but think of it in terms of math, so don't overthink this. We'll do some practice in class, but just kind of come in understanding giver, grabber, combine together. Okay, so let's take another example. This is sodium over here, and this is bromine over here. I've got a plus 1 and a minus 1. I decided let's make it easy for our first one. Okay, so I have a sodium and a bromine. When they combine, it becomes sodium bromide. Okay, so the second element is going to change its name. So think of it like we got married and we changed your name. Okay, the second element is always going to do that. So the grabber is going to change its name. This tells me when I see sodium bromide, I'm talking about a compound. If you were to write sodium bromine, then I'm thinking sodium the element and bromine the element. So keep that very much in mind. That letter change is a big deal. To represent it, I've got one sodium, I've got one bromine, put them together, sodium bromide. My formula is NaBr. Remember, I don't need to write the ones in, okay? In class, we're going to do several examples of these, so don't worry, we'll get plenty of practice. But if you have any questions, please make sure you ask me, and go back through these, okay? So when we think about this point right here, make sure, and I'm going to skip back, I want you to go back and I want you to think of our positive ions, the fact that it has this one extra, and this negative ion who really needs to fill that spot. And when we work together, we make a compound that's stable and happy. All right, if you have any questions, please see me, and I will look forward to talking to you about this in class.